In this demo, we'll continue working on the homepage for the tennis booking application. We'll see how we can access and reference individual sections from the configuration. And we'll also see how we can use string configuration values. We'll focus on how we can control the display of a weather forecast using application configuration. We now need to access a second configuration value from the homepage subsection of the features section. We could do this as we did a few moments ago by providing the full key name. However, it's more convenient not to have to retype the flattened hierarchy for every setting we want to access. Instead, we'll use another approach and refactor the onGet method. First, we'll get a reference to the section that we're interested in. We'll do this by creating a local variable and setting it by calling the getSection method on the iConfiguration instance. We provide the flattened section and subsection name as the argument for this method. The getSection method returns an iConfiguration section instance, which provides access to the values within the requested section. We can now refactor the getValue call used to get the enableGreeting value. Instead of accessing the key from the root of the configuration, we can now access it from its owning section using the local homepage features variable that we just created. We now only need to provide the key name, and we don't need to provide the flattened section names. We can use a similar approach to load the value for the Enable Weather Forecast setting. We'll set the Show Weather Forecast property on the model directly using this value. I'll paste in some code which will control the display of the weather forecast information. That includes setting the title for the weather forecast, which will appear on the homepage. The configuration we added to the app settings JSON file included a string value which can be used to control the title. Let's look at how we can consume that configuration value. By default, any values accessed from configuration are treated as strings. Therefore, in this case, we can access the title value directly via the indexer on iConfiguration section. We can provide the forecast section title key to get the value for the referenced entry. We use the configured value to set the property on the page model. The pasted code also retrieves a weather forecast for the town of Eastbourne and sets the current weather variable. The weather forecast summary is then used in this switch statement to set a more detailed weather description for use on the homepage. You'll notice that we have a compiler error here because the pasted code depends on a weather forecaster that's not yet available. We'll return to the constructor to include an extra parameter to allow an iWeatherForecaster to be injected. The dependency injection container for this application is already configured with suitable services that can resolve and provide this dependency. We'll allow the tooling to create and assign a field for this parameter, fixing the compiler error. Let's take a look at the Razor page code for the homepage. Here is a section which will be rendered when the Show Weather Forecast property is set to true. It uses the Forecast section title property, loaded from configuration, as its header for the content. Let's run the application and see the result of these changes. The homepage is loaded and it looks the same as before. We have the custom greeting, but the weather forecast is not shown. So what have I done wrong here? Here's the app settings.json file that we updated earlier. When we added the Enable Weather Forecast configuration entry, I set its value to false. As a result, the weather forecast is disabled on the homepage, so it's correctly not being shown. We'll change the configuration to enable the forecast and restart the application. This time, the weather forecast is loaded and it's shown on the homepage. This is an example of the benefit of configuration. We didn't need to recompile the application to update its behavior. All we had to change was a value in the configuration file. In this demo, we'll explore how to access configuration for our application when it first starts up. Configuration may be used at startup to control the services registered for an application and the application middleware pipeline. We'll see how the default ASP.NET Core template uses configuration when registering the Entity Framework database context for the tennis booking application. When I introduced the app settings.json file, we saw that it included some default configuration entries. For example, when creating a new ASP.NET Core project, If you opt to use local identity-based authentication, it will use a database to store the user data. Accessing the database requires a database connection string, which is defined in the appsettings.json configuration file. A default connection key is included within the connection string sections in the default template. In the tennis booking application, I've opted to use SQLite, and I chose to name the key appropriately in the appsettings.json file. In ASP.NET Core 6, services are registered within the program.cs file. If I open the program file, we'll see where this configuration value is used. This file uses the C#9 feature called top-level statements, and it's the entry point for this application. To support using a database accessed through Entity Framework, the DB context needs to be registered, which is achieved by using the add-db-context extension method on the iService collection. The Microsoft Identity Services will use this DB context to access the user data. When registering the database context, we can provide options including settings for the database server that we want to use. In this demo application, we're using an SQLite database connection. The useSQLite method takes a connection argument accepting a DB connection to use. Scrolling up to the top of the file, we see the creation of the connection to SQLite. It's here that we need to use the connection string as defined in the configuration. We may access an iConfiguration instance on the Web Application Builder. The configuration library includes an extension method for iConfiguration called getConnectionString, which can be used to access a named connection string. This takes a string argument, which is the name of the connection string we wish to access. This extension method will look for a key with a matching name within the connection string section of the configuration. It uses the string-based indexer available on iConfiguration and iConfiguration section to access the configuration value. Previously, we added configuration values used to control the display of the weather forecasting feature on the homepage. Let's assume that the weather forecast feature may be used on other pages across the application. We would now like to include a master feature switch which can enable or disable the feature across the whole site. We'll add another subsection under Features. We'll add a key here named Enable Weather Forecasting, which will control the global availability of the weather forecasting service, allowing us to disable it in all locations with this single master switch. To date, the application has been using a random weather forecast implementation. We'll take the chance to update it to access the forecasts using our Weather API service. We'll add some additional configuration to control access to external services. I'll paste in a new section to define this. For the Weather API, we require the URL for the service, so I've included a configuration value for this. The services used to provide the weather forecasting functionality are registered using an add weather forecasting extension method on the iService collection. If we navigate to this method by pressing F12, we can review and update the code. There are two abstractions here, an interface called iWeatherAPI Client. This is a typed client, a feature available as part of a Microsoft extension library that manages HTTP client instances using a HTTP client factory. The code also registers an iWeather Forecaster interface, which provides a higher level of abstraction and is intended to be the main dependency injected wherever weather forecasts are needed. This service is decorated with a caching implementation. If you'd like to learn more about service registrations in ASP.NET Core, I recommend you add my course, Dependency Injection in ASP.NET Core 6 to your watchlist. The currently registered implementation for iWeather Forecaster is provided by the Random Weather Forecaster class. We'll modify this to use an alternative implementation named Weather Forecaster. This requires us to add a using directive for the tennisbookings.services.weather namespace. The Weather Forecaster implementation connects to an external service over HTTP via the iWeather API client in order to access weather forecast data. The iWeather Forecaster interface defines a forecast-enabled Boolean property. In the Weather Forecaster implementation, this is hard-coded with a value of true. You may reasonably wonder how I'll control this feature using configuration if its property is hard-coded. A valid approach here would be to depend on iConfiguration inside the Weather Forecaster implementation and then use the configuration value to set the property. For this demo, I'll use a more sophisticated approach which can be helpful in some situations. Occasionally, you may want to register different services for your application based on application configuration. So let's see how we can achieve that. The tennis booking project includes another implementation of iWeather Forecaster called Disabled Weather Forecaster. This implementation has forecast enabled hard-coded to return false. We'll now set up the application to register the appropriate version based on configuration. To support conditional registration of the services, we'll add an iConfiguration parameter to the extension method named config. We can use a technique that we saw previously to access the value of the Enable Weather Forecast key from the Weather Forecasting section. When the feature is enabled, we'll register the required services. When it's disabled, we'll register only the disabled Weather Forecaster instead. This ensures that consumers of the iWeather Forecaster can still depend upon and call methods on the interface without it throwing exceptions. Since we've updated our Add Weather Forecasting extension method to require iConfiguration as a parameter, we'll need to update our call to it from the program file. Here we can pass a reference to the iConfiguration from the builder. If I run the application, the home page displays the weather forecast. Let's update the configuration to disable weather forecasting across the whole application. When we rerun the application, we now expect the forecast to be hidden. Unfortunately, it's not. That's because we still need to update some of our application code. We can update the logic in the onGet method for the index model to check the forecast-enabled property from the iWeather Forecaster dependency in addition to the homepage configuration. Only when this feature is enabled both globally and for the homepage should we show the weather forecast. After this change, if we rerun the application, the weather forecast is now no longer shown. Although it's still enabled for the homepage, the master switch means that the disabled weather forecaster service that's been registered no longer considers the feature to be enabled. This technique is not something you'll need to apply everywhere in your application, but it does demonstrate the power of conditionally registering services based on configuration values. Another use case would be to register different services for different environments, perhaps using a fake implementation of a dependency during development. Manually obtaining configuration values using hard-coded keys can become tedious since you must type the section and key names every time. This approach is also quite fragile, since changes to the naming of configuration entries may cause your keys to become invalid, and that can lead to bugs in your code. So why have you just spent time explaining it then, Steve? You might very well be asking, and that's a fair question. In smaller applications and simple scenarios, it can be quicker to start with accessing configuration directly. Though, as we've seen in the demo so far, as your application depends more and more upon configuration, sections of your code may become quite busy.